Have to simplify rational expressions and not sure where to start? I'll give you a few tips and a bunch of examples, so hopefully that'll help. Hi, I'm Aaron Hayes. I'm one of the math teachers here at West Chicago Community High School, and I'm just going to run through this so that you've got just some basic steps, and hopefully the examples will help too. These are kind of the four things, and a lot of which you probably have already done when you're doing multiplying and dividing rationals. You need to factor everything that you can first, because that will help you see the next part, which is the common denominators, which work in terms of how to piece those together. After that, you're going to combine the two different parts after you find the common denominator, and then you're going to simplify it and put it, especially the numerator, into a new polynomial. And then after that, if you can, you're going to factor it, and then after that, we're going to simplify it much like you did when multiplying. Okay, so when we go through this, pause where you need to, rewind where you need to, but I'm just going to kind of work your way through these. Really seeing examples is probably going to be your best bet. So here we go. First example over here. I would say get into the habit of trying to figure out what your common denominator is. So over here, I've got a 2 and a 3, so that'll be 6. And then I'm going to have k squared. And you're going to multiply, or you can think of it like this, 2 times 3 times k. Because whatever's going to miss, that's what we're going to fill in. So over here, I'm going to go 2 over 2. Over here, I'm going to 3 over 3. So that's going to give me to the 6. I do have k squared over here on the right-hand side, so I need to multiply through by k there. Now, eventually, I don't think that you'll end up needing to write this part over here. I would do it separately initially, just so you can kind of more consciously put it in your head. And then after that, eventually you can just kind of put the common denominator down here. From here, I'm going to multiply this out, so 2k times 3 is 6k. 7 times 3 is going to be 21, and since I'm adding in the middle, 21k, excuse me, then you're going to go ahead and do that. So now this is where I was saying in that third step, we're going to simplify this, and I'm going to get 27k over 6k squared. And then from there, you're going to go ahead and simplify it like what we did before. So in this case here, I can divide a 3 out of the top to the bottom. That's going to become 9 over 2. And then the k will stay down in the bottom. And there is your simplified form. Okay, and again, remember, do the coefficients separately from all the variables. So try to, do the coefficients, then worry about whatever variables you have. Okay, so again, pause where you need to. So for example, if you wanted to try this one on your own, pause it, see where you go, and then release it. So then over here, your common denominator is going to be, now here we're going to take whatever we have in each of the factors, okay? So I've got an x plus 2. That is over in the first part of the rational. So we're going to take that. We're also going to take the x minus 3. Now in the second one, we have another x minus 3, so we're going to just leave that because it's already part of that, and we're going to go from there. Okay, so our common denominator here, we want to multiply this out. So both sides have x plus 2, x minus 3, and x plus 1 in the denominator. So first side, we don't have that x plus 1, so I'm going to multiply that through. And then I'm going to do the same thing over here. Now this side's missing the x plus 2, so I'm going to multiply this by x plus 2 over x plus 2. Now, I always get asked, do I need to multiply out the denominator? The answer is no, because remember, we're going to do that simplifying. And so if you end up multiplying it out, you're going to just have to divide it out later. When I multiply the first part here, I'm going to get 3x squared plus 3x. The second side is going to turn into 2x squared plus 4x. And then when I combine all of that together, so again, I'm going to simplify the top. And I'm going to get 5x squared. Sorry if you hear the lawnmowers. I'm trying a different mic setup today. I don't think this one is noise canceling. I'll see what I can do in post-production. Now here, the only other thing that I'm going to suggest doing now, it's maybe obvious to you that nothing's going to divide out. I would say factor out, and I tell my classes this, factor out whatever you can, because that at least shows that you looked. I think on all of our questions on assessments and such, that's going to be possible. I'm not saying everything divides out, but at least that way I know that you looked for it. Okay, so that's going to be some of the types of stuff that we look for. So over here, notice nothing divides out because there's not an x in the bottom. There's not a 5x plus 7 in the denominator, so we're just going to go ahead and leave it. And this is your answer. Another example. This one a little different. We have a monomial and a binomial in the bottom. So our common denominator is going to be those two multiplied together. Sometimes people think, oh, I already have an x, I don't have to worry about that. But remember that this is a monomial, this is a binomial, and you can't just kind of merge things as you want. So this side is missing an x minus 4, so I'm going to multiply through by that. This side over here is missing a 5x. So again, the common denominator is already set up down here. Sorry for the mess. And on the top, I'm going to get 3x minus 12 minus. Now here's the other thing, and I would change this to adding and put the negative up here so that it can distribute that correctly. Whenever that doesn't happen, I tend to see lots of mistakes, and that's not fun. Nor is it fun to grade. So then from here I get negative 7x minus 12 over 5x times x minus 4. It's tempting to, now the top doesn't factor, so at this point this would be your final answer. You can't divide any of those parts out because everything in the top is an add-in. It's part of an adding and not a factor. Okay? What do you think we need to do here? Pause, take a swing, see what you come up with. Just like before, you're going to have to factor things, okay? Not a problem. But also like before, it is probably going to make sense to, it's going to make sense to kind of use this to figure out what's factoring over here, okay? So if you weren't sure about how this factors, you could say, okay, well, is it going to make sense that x plus 2 or x plus 1 is going to be part of it? Now, it's not always guaranteed, but it's not a bad thing. And so you know x plus 1 could be it because 2 isn't part of that 3. So sometimes you can reverse engineer it that way. So your common denominator here, you're going to take one of everything, or at least I should actually say the most times a particular factor happens. So I get those, I get the 2x minus 3, and that one stays. So in the top, this one is missing my 2x minus 3. I tend to write this always in parentheses to make sure that I distribute things correctly. This one's missing the x plus 2. So then from there, I've got 2x squared minus 3x plus 2x squared plus 4x. Combine things out. The denominator is going to stay the same, so hopefully we can divide some things out. I promise you there'll be at least 1 or 2 in here that will do that. And then across the top, I will get 4x squared plus 1x. So it doesn't look like it's going to work because on the top I can factor out an x, and on the bottom and that. Okay. So with that, here we go. So again, that's, I mean, it's not, I don't know. It doesn't feel messy, it just feels involved. I would say do not try to save paper on this. Don't try to skip steps. People who do that tend to not do well. If you need more paper, I will give it to you. Don't worry about that. This one, we got a minus, so we need to worry about that. I'm going to go ahead and change this before I even worry about it. This is going to factor into, and again, pause if you want to take a swing at this first. So this is actually going to have a common denominator of this, a plus 1, a minus 1. On the top, we're missing, so the left side's already all set. That's beautiful. This side over here is missing a -1. So here I'm going to get the first numerator, because we're not touching it because the denominator is already all set. The second one, I'm going to end up with the opposite of a plus 1. Again, make sure that when you do this, the negative's going, because I'm doing this and this. So that last one is going to turn into a plus 1. And again, that's going to be the places where people make mistakes. So get into some good habits now. I get 2a plus 2 over a plus 1, a minus 1. Now the top, hopefully you're already seeing, hey, I can pull out a GCF. GCFs always get forgotten. That doesn't sound like proper English there. So you get those. Say goodbye to a plus 1. Okay. And so again, it's just a matter of just doing the things that you already know how to do. You're going to factor it. You're going to find a common denominator. You're going to multiply things out. And then you're going to just recombine, factor again, and then simplify. Okay? So most people by about day 3 of this find that it's daunting, not so much because it's hard, it's daunting because there's lots of steps and easy sometimes to make mistakes. But if you just go be intentional, don't try to go fast, just be intentional. So you're slowing down just a bit to make sure you don't make any mistakes. All right, so last problem, a couple of things. Notice here, this could factor into this, right? Which is the opposite of what I need over here. And so if I could flip that around so I got the y squared out front, that would be helpful. So what I can actually do is I can factor out a -1 here. Negative y, the opposite of y squared divided by y, -1 is going to be y squared. Positive 25 divided by -1 is going to be -25. So then this is going to lead me into that as the denominator for the left-hand side, and that's going to be the same common denominator for the whole thing. So whole common denominator is going to be a -1 times y plus 5, y minus 5. And again, there's a little trick I'll show you at the end that you may have already seen, which if you're wondering, hey, couldn't I? The answer is yes, probably, if it's what I think you're thinking. So I'm going to multiply this through by -1. I also need to multiply this by y plus 5. We do the same thing here. Move that up there, -1, y plus 5. So I do that, I get 3y plus 15. This is going to turn into a positive 2. Multiply that through, I get 2y plus 10. So I get this. This top part here is going to factor out to become y plus 5. So that means that these are going to go away. I'm going to divide the negative into the 5, so I'm going to get -5 on the top and y minus 5 on the bottom. Now you may be wondering, hey, Mr. Hayes, what about that 3y plus 15? Couldn't I factor? And the answer is yes. This is not always going to work, but in this case it certainly works out really nicely. So if I do this, keep the same denominator. Notice here your y plus 5s are going to go away. I'm going to keep this here. So these are going to go away. So the very nice thing is now I have the same denominator. I don't even have to use I'm using a common denominator, but I'm not making one. I'm going to divide this up into here. So that's going to become a -3. And so then that's going to shift me right into -5 over y minus 5. So I hope that helps. Obviously, comment, like, subscribe, all that other good stuff, and I'll see you next time.